be very careful reading and interpreting the statements in this class, because there are times when statements look true at first, and it may be difficult to find a counterexample, but they are sometimes false. So for example, in this problem, we're being asked, is it true that for all integers a and b, if a divides 10b, then a divides 10 or a divides b? So if you choose the wrong a, b, c, then you may end up thinking that the statement is actually true, whereas it's probably false. So like for example, here's a false counterexample. I could pick a to be 2, and so in that case, 2 definitely divides 10b, because 2 divides 10. So it seems like the theorem is actually true, or the statement is actually true, but this is not the correct counterexample. This is actually a false counterexample. I can tell you about an a that divides 10b, where a does not divide 10, or a does not divide b. For example, if I pick my a to be 4, and I pick b to be 2, then for sure 10b is going to be 40, and I'll know that the a in this problem, which is 4, divides 40. That's 100% right. However, in this problem, if I pick a to be 4, then 4 does not divide 10, and at the same time, 4 does not divide the 2, which is b. So the theorem seems to be actually false. And that's what we're going to do in this problem. We're going to show that this theorem is, in fact, false. So in my proof, I'm reminding you that this is an example of a universal statement. And the universal statement is saying that for every integers a and b, if a divides 10b, then a divides 10, or a divides b. In my case, I am saying that this statement is false. Well, what is the negation of the statement? The negation is that there exists a and b, with a dividing 10b, and a not dividing 10, and a not dividing b. Remember, when I am negating universals, I'm going to end up with existentials. And then the negation of the if-then statement is going to be an and statement. And keep in mind, the Morgan's law has to apply. That's the reason why this or is being changed into an and. So that's the reason why we spent a lot of time studying logic at the start of this semester. So we will show that the negation is true by finding the correct counterexample values. In this case, I am going to find a number a that divides 10b, but the number a will not divide 10, and it will not divide the number b. My choice here is a to be 8, b to be 4. So first I'm going to show you that a divides 10b by finding 10b to be 40, which means that a divides 40 is in fact true. I have to actually state this. This is important, and it has to be written down as part of your proof. However, 8 does not divide 10, and 8 does not divide 4. So the statement above is false. So that's what we wanted to show in this problem. So notice how complicated and how thorough my proof was. I did not just write down in the middle of the page a is equal to 8 and b is equal to 4, and then I just moved on. I actually explain in detail exactly what I'm supposed to do and exactly what the proof is all about. So this way, there's no way on earth somebody can come and say, hey, I don't understand this one step. Everything is justified. And I'm not jumping to a conclusion. I'm leading the reader step by step through the whole proof. That makes a good proof.